Good evening, everyone, and on behalf of BCS and IET, welcome to the Royal Institution and to the 2015 Turing Lecture. My name is Liz Bacon, and I'm the current president of BCS, the Chartered Institute for IT, and it's my great privilege to chair the lecture tonight. A warm welcome also to those around the world watching on the IET.tv. Before we start, we'd be grateful if you would ensure that your mobile phones are switched to silent so that we're not interrupted. We would, however, like to invite you to tweet during the lecture, and you'll see the hashtag for this evening is Turing Lecture, all one word. If you hear a continuous ring, it is the fire alarm, and it will be for real as we don't have any drills planned. If that does ring, please will you evacuate the building through the nearest exit and assemble outside Aspreys, located round the corner on Grafton Street. Staff, of course, will be at hand to lead the way. In honour and recognition of Alan Turing's contribution in the field of computing, BCS and the IEE, as the IET used to be called, established the Turing Lecture, with the first lecture being presented in 1999. It is a world-leading event presented on a topic from current research in computer science and is given by an acknowledged expert in the field. We are thrilled to honour Alan Turing again this evening at the 17th edition of our Turing Lecture. However, before we start, I'm delighted to be able to invite Dermot Turing, the nephew of Alan Turing, to say a few words about his charity, the Turing Trust. Thank you.
Thank you very much. It's a privilege to be here. It's a quite interesting year to be Alan Turing's nephew, as you can probably imagine. As I got off the plane from Hollywood, et cetera, et cetera. Actually, if I might, just one word about the imitation game. You will know, if you've seen the movie, that it features a piece of equipment in it which purports, according to the script, to be essentially the predecessor of a programmable computer, which is kind of half true. Two things I'd like to say about that. First of all, that piece of equipment, the bomb, which was used for breaking the Enigma codes during the Second World War, is actually available for you to go and see at Bletchley Park. And I would like to acknowledge the contribution made by the British Computer Society to the bomb rebuild team, who actually reassembled a bomb without the benefit of any contemporary schematics. And they had some help from GCHQ with blueprints and so forth, but without the help of the BCS, I don't think that exhibit would be there to see. But anyway, I encourage you to go and see it, and then you can find out the real truth behind the imitation game. But anyway, when I'm not busy being a film critic and collecting Oscars and all the other things that keep my life very tedious, I am actually a trustee of a small charity called the Turing Trust, and it's very kind to be given this platform to tell you about it. Some of you may have heard this before. It's very simple. What we do is recognize that the lifespan of a piece of computer equipment in the UK is roughly 3 years, and those of you who work for any kind of organisation will recognise that your computers basically get chucked out after 3 years. And what we try to do is to ensure that they don't end up in a skip, don't get turned into something called e-waste, but actually are put to use in less privileged countries than ours, and we have an arrangement to ship them out to schools in Ghana and indeed in some other African countries, where we can ensure that they are made available to students to learn computing skills that otherwise they wouldn't have the opportunity to do. So please don't give us anything that doesn't work, but on the whole, your obsolete stuff is probably great for kids learning really basic stuff in Ghana. So there are some leaflets. Some of you may have seen these outside while you were having your coffee, but if you didn't get an opportunity, there'll be some downstairs on the way out. So please let us have your old PC and laptops. And thank you very much for listening.
I'd now like to introduce our esteemed speaker this evening, Dr. Robert Pepper, who is Vice President, Global Technology Policy at Cisco. Robert leads Cisco's Global Technology Policy team, working with governments across the world to develop strategies and address areas such as broadband, IP-enabled services, wireless and spectrum policy, the Internet of Things, security, privacy, internet governance, and ICT development. His work on strategies and policy incorporates his extensive work on internet and technology trends. He joined Cisco in July 2005 from the Federal Communications Commission, where he served as Chief of the Office of Plans and Policy and Chief of Policy Development beginning in 1989, where he led teams developing policies promoting the development of the Internet, implementing telecommunications legislation, planning for the transition to digital television, and designing and implementing the first US spectrum auctions. Before joining the Federal Communications Commission, he was director of the Annenberg Washington Program in Communications Policy. His government service also included acting Associate Administrator at the National Telecommunications and Information Administration, and initiating a program on computers, communications, and information policy at the National Science Foundation. His academic appointments include faculty positions at the universities of Iowa, Indiana, and Pennsylvania, and as a research affiliate at Harvard University. He serves on the board of US Telecommunications Training Institute and advisory boards for Columbia University and Michigan State University, and is a Communications Program Fellow at Aspen Institute. He is a member of the US Department of Commerce's Spectrum Management Advisory Committee, the UK's Ofcom Spectrum Advisory Board, and the US Department of State's Advisory Committee on International Communications and Information Policy, and the UN Broadband Commission. Dr. Pepper received his BA and PhD from the University of Wisconsin-Madison. I'd now like to warmly welcome Robert to give the 2015 Turing Lecture. Thank you.
Thank you very much for the very, very kind introduction. It's an incredible honor to be asked to give the Turing Lectures, and then doing it here in this hall where Faraday actually gave his lectures. That's pretty amazing when I found that out only yesterday, that that's where we were. And of course, last year, and the previous years, some of us knew who Alan Turing was, but because of Hollywood, the world knows who Alan Turing is. And so it's even a greater honor to be here doing this. So a little bit about myself and some of the context. You heard, and thank you, very nice bio. But I think of myself as a recovering regulator, right? I wake up every morning. I mean, you heard I was at the FCC. I wake up in the morning and I look in the mirror and I say, I'm a regulator, but I haven't regulated today. It's the first step in the 12-step program for recovering regulators, right? And that's very relevant for what I'm going to talk about today, because it's about the intersection of technology and policy. And one of the things that, as a former recovering regulator, governments and regulators need to be very humble, especially when it comes to technology. Technology that's moving at a very rapid pace. And as you'll see, this is why I called the talk the Internet Paradox. Because there's some trends, and I'm going to start with the trends in computing, from big iron to the Internet of Everything. I'm going to talk about policies and governance of the Internet, and then the paradox, and then the crossroads. And we're at a very important juncture. But as part of that, we need to think about the appropriate role of government, private sector, the academy, the technical community, civil society, in what is, and I'll talk about this, in what's now called the multi-stakeholder approach for Internet governance. So from big iron to nanocompute, right? It was big iron. It was centralized. There were only a handful of computers. In fact, you've all heard the predictions that we were only going to need a handful of computers. But today, compute has become miniaturized. If we follow the advances through the decades of computing, we went from big iron in the 50s to mainframe computers in the 60s, mini computing in the 70s, personal computing, laptops, mobile computing, and now it's wearables, microcomputing. And we haven't even seen, the Apple Watch is going to be released in April. Samsung, Google, Motorola, Lenovo, they've all released watches. There are all kinds of wearables. So we're now in a world of where compute is not only miniaturized, but it's less expensive and much more powerful. What this shows is the cost of a calculation per second. In 1960, it cost $1,000. It was a big deal. You could calculate one calculation per second for $1,000. Today, we can do 10 billion calculations per second for $1,000. So the cost of computing has come down, the power of computing has increased, and as a result, what we've seen is a decentralization of computing. It's no longer centralized. And we can talk about cloud computing, because even with cloud computing, it's decentralized data centers that are all connected globally by the internet. So we've seen computing become decentralized. We've also seen the internet grow. So in 1969, when internet protocol was developed, packet switching was developed, there were 4 locations that were connected. 3 in California and 1 in Utah. By 1970, 1 year later, there were, and by the way, these are principally academic computing centers using packet switching. A year later, universities and research centers on the east coast of the United States were connected. 2 years later, 3 years later, we had the first international connections by satellite. London and Hawaii. Although Hawaii is still in the U.S., it's not in the continental U.S. So, the international connection here was London. By 1993, the internet had become global. And something else important had happened. There were decisions, by the way, let me just, the lines here, the thickness of the lines represent the amount of traffic on these routes. So we see not only are the internet connections global on every continent, except maybe Antarctica, but the traffic patterns back then, right, we're looking at 20 years ago, 22 years ago, predominantly North America and Western Europe, but global. So there were routes everywhere using internet connections. But something very important happened in 1992 through 93, 94, 95. And it was essentially decisions by the US government to privatize the internet and the internet activities. We had created the National Science Foundation Network, the NSF-Net. And as mentioned, I was at NSF, and it's one of the projects that I was affiliated with, I was working on when I was at NSF, was creating NSF-Net to connect research centers globally. In the 90s, the decision was made to eliminate restrictions on using the internet so that it could be used for commercial purposes. At the same time, the governance through the distributing and using the resources of the internet were privatized from the National Science Foundation to other organizations. That drove the internet and its use and extension globally. By 2008, it looked like a galaxy. And if you look at it today, it looks like something, a photograph or an image that would be taken by one of the deep space telescopes. Each one of those bubbles, each one of those dots is a domain in the internet. The big blue ones, and by the way, it represents the amount of traffic. So the biggest blue right there in the middle is Google. The one up at about 2 o'clock from that one is Facebook. There's also YouTube. But when you look globally, if you look to the lower left, all of those yellow-green bubbles, those are all of the Chinese websites and domains. Baidu is the largest one in China. Every continent have domains with internet traffic. Every continent is connected. The internet is completely global. Another way to think about this with this diffusion of the internet, this decentralization of the internet, the globalization of the internet, is to think about the evolution of the internet in stages. The first phase, the first stage of the internet was about connectivity, email, web browsing, search. Oh, and by the way, the vertical axis is the business, the economic, business, and social impact of the internet. And then you have the number of intelligent connections on the horizontal axis. The second phase was the network economy, e-commerce, digital supply chain, collaboration tools, followed by really where we are today. It's all about social, mobile, video, cloud, immersive experiences, social media. But when you think about it, even with all of the things that are connected, only 1% of the things that could be connected are connected to the internet. In fact, in 1984, we went back and we looked, there were only about 1,000 computers in the world connected. And we're now forecasting that by 2020, there will be over 20 billion internet connections. These are devices with internet protocol IP addresses. If you include things that don't have IP addresses, like little RFID chips and some of the others, that number is going to be 50 billion things connected. But I'm just focusing here on things with IP addresses. So when we think about the next phase of the internet, it's really about the Internet of Everything. And the Internet of Everything is not just about the things, but it's connecting people, process, data, and things. And what that means is that the benefits and the impact, we believe, of the Internet of Everything is going to be even greater than the impact of the Internet that we know today. So just two examples. We're forecasting that by 2018, there'll be about 250 million connected cars on the road around the world. And in each one of those connected cars, there will be, on an average, of 4 connected modules, 4 modules with IP connections. And each module will have multiple sensors. That's just one example. We're all familiar with, wearables. This is from a French company, and there are companies around the world for athletes. Sensors that are connected in the clothing that, provide feedback to the athlete. It also can provide all kinds of other, feedback to the coach, to your doctor. It can be recorded. But, the devices that are generating the data, whether it's cars or wearables or smart grids, and I'm going to talk about some of the others, the things by themselves are not particularly interesting. They all generate data that's a little bit more interesting, but data by itself is really not very interesting. It's only interesting when you can use it, when it becomes actionable data. So the data has to be processed and turned into information into knowledge, and then insight. When you have insight from the data, that's when it's actionable. And when you have insight from the data that's actionable, that's what can affect and change people's lives. So we like to talk about the things that generate the data that then can affect process. And when you change process, you can affect people's lives in a very positive way. And also process can change, manufacturing process, supply chain, medical process. And I'm going to talk about some of these examples. But there's something else, right? If only 1% of the things that could be connected are connected, less than 0.5% of the data from that 1% of things is even being analyzed. The vast majority of the data is not even stored, it's just tossed. Think what you could do if you actually had the ability to analyze the data. Less than 0.5% of the data that could be analyzed is being analyzed. Some examples. So the Internet of Everything is really reinventing things that we know. It's reinventing diet and nutrition. This is a real-world example. It's an application that incorporates it's a health assistant. It's an augmented reality assistant that helps people maintain their diet, that helps people decide what foods to eat, that are nutritional, that are part of what the doctor prescribed. So you can go into the store, you can take out your smartphone, hold it up, and take a picture of the food, and it will look at it and analyze it for you and tell you if it's good to eat. Right? On the other hand, there I am buying beer, and it says, sorry, you can't drink alcohol with your meds. One of my favorite examples is something called the Proteus pill. One of the biggest problems older people have is they forget to take their medications. And if they forget to take their medications, they could end up in hospital with an emergency trip, with fire, with the ambulance. It also can be life-threatening. So Proteus, a company in the US, had this really, really great idea. What would happen if you could have a chip the size of a grain of sand and put it inside the pill, and then when you swallow the pill and you digest it, the stomach acid reacts with the coating on the outside of the chip, chemically reacts, gives it enough energy, so it wakes up and it chirps and it says, hello, I'm here. Up in the upper right, that thing up there is a patch that you wear taped to your stomach. So the pill communicates from inside your stomach to the patch. The patch then communicates to your smartphone or your Wi-Fi base station, and then it communicates back to your health provider, doctor, nurse, or family member. All they want to know is that the pill said hello, right? If the pill doesn't call home, right, you go to your, grandma, please take your pill. This, by the way, is not science fiction. It's been approved by the US Food and Drug Administration. It is in the market. It's helping people, and it's avoiding traumatic trips to hospital. It is saving money. It's saving lives. A little more mundane is the reinvention of how do I catch a cab? I ran into this 2 days on Saturday when I was leaving Washington to come to London. I probably made a mistake, but I used the old traditional way. I called up, I booked a cab. They were supposed to be at my home at 1 o'clock. It was snowing, sleeting, it was bad weather. 1:30, they weren't there. So I called them. They said, oh, I'm sorry, it's booked, it's reserved, but we can't find drivers to come. I said, well, I have to get to the airport. So they said, well, no guarantee, we'll keep trying. What did I do? What I should have done in the first place. I went to my Uber app, right? And immediately I had a reply, we'll be there in 12 minutes. Right? Now, he didn't realize that I live where there are hills and he was sliding. It took a little longer. But he was there, completely reinventing how do you call a cab. Now, there's some, this is from a patent filing on reinventing diapers. right? And I looked at this and I said to a friend, I said, do you really need to have a connected diaper if you have a good nose? And she was a new mother, and she said, no, she said, this would be great because when I'm downstairs, I need to know whether the baby needs changing, right? So she's ready to buy these when they're in the market. So maybe it is an intelligent future, not an unintelligent one. But what about policy? What about governance? So what we've seen so far is this trend towards nanocompute, decentralization of computing. Instead of big iron, 20 billion compute devices distributed around the world by 2020. So we have a trend of decentralization. We have a trend of decentralization within the internet. And in fact, the internet governance process has been very, very bottom up. It's interesting, the Internet Society conducted a study recently, and they asked people, who governs the internet? 28% of people said, oh, the telecom company, the internet service provider. Another 20% said the big search engines, the Microsofts, the Googles. The truth is, it's an ecosystem. It's a combination. It's only 15% of people got it right. It's a combination of government, private sector, technical community, civil society, the academic community, all working together, and this whole process grew up organically, bottom up. And if you think about it, and these are some of the examples, and I don't expect you to read the parts of this that are off the little fingers, but we're starting with open standards and working counterclockwise. So starting over there, the community that develops the standards for the internet includes organizations like the Internet Engineering Task Force, the Internet Architecture Board, that are part of working with the Internet Society and the affiliated organizations. But it also includes the World Wide Web Consortium, the ITU, other standards bodies. There's not one, but it's a group, and it's really very much voluntary. There are, in terms of the global services and operations, there are network operators. There are the people who manage the root servers, the internet exchange points. Then, of course, there are all of the users, individuals, business, government, universities, academics, researchers, education and capacity building, including government, the Internet Society, academics, multilateral institutions, the UN Broadband Commission that I sit on. And then there are the governments that are developing the policy. Local governments. The Internet Society is a private sector participant in that. Global organizations, national governments. And then there are the naming, addressing, and other parts of managing resources for the internet. And some of you may be familiar with the current debates about what's called the IANA transition, which is the Internet Address and Numbers Administration, which is managed as part of ICANN, which is the organization that was set up. Remember, I talked about privatizing the domain names. So it's the Internet Corporation for Assigned Numbers, Numbers and Names. And there's this transition process to complete the privatization of that. But this is a multi-stakeholder process. It's an internet ecosystem. It's not a single point. It's not a single government. It's not even what they call a multilateral organization. Multilateral are places like the UN, the International Telecommunications Union, other organizations where governments come together in multilateral organizations operating under multilateral treaties but only governments get to play. This is a multi-stakeholder approach, including government, but including all of the other parts of society, business, individuals, and it's global. If we think about this also, on the vertical axis are connected devices, and then we have time. Going back to the very beginning, 1969, there was the first request for comment. It's called an RFC, and it was issued and circulated via ARPANET, which was the research organization that actually funded that picture of the internet connecting the 4 research institutes I showed you in 1969. There's a guy named Steve Crocker who actually wrote the first request for comment. Steve, by the way, happens to now be the chairman of the board of ICANN. So Steve has been very active in this from the very beginning. But if you look at some of these benchmarks, some of these events over time, even before the internet began to grow in the early 2000s, you had the first meeting of the Internet Engineering Task Force in 1986. You had in 1998, I mentioned the privatization of some of these functions. The IANA function was transitioned to ICANN. On some of the privacy questions, I say privacy, you say privacy. In 98, it was the beginning of the US-European Union Safe Harbor Agreement for protecting personal data. The first Internet Governance Forum was 2006. And I'm going to come back to this one in 2012. There was a global meeting called the World Conference on International Telecommunications. And there were a set of, among other things, this is a meeting held periodically by the International Telecom Union, the ITU, to look at telecom regulation. Right? And they do a really good job at that. There were proposals by some member states put into the ITR process that would have regulated the internet. Those proposals were rejected. That was 2012. And then today, as I mentioned, there's the proposal from the Department of Commerce in the US to complete this global and privatization process for the IANA functions. And that began this last year in 2014, and the process to do that is underway. A lot of what you see here in terms of all of these activities were done by volunteers. It was very bottom up. It started as an academic endeavor. In fact, John Postel was affiliated with University of Southern California, and John actually managed the domain name system, literally. I mean, and there you see him. John was the one that came up with the country names, right? So, you know, U.S. is easy, U.K. is easy, but then there were some of the others that were not quite as easy. But you know, John did this, but he did this with other academics involved in the internet. All right? And there was this peer process, this academic peer process. It grew very organically. It was very bottom up. And in those days, when you had 1984, 1,000 computers connected, that was it. Everybody knew everybody on the internet, right? And it was easy. It's not quite as easy today. I mentioned standards, right? So the traditional standards process, which you see on the right, whether it's at the ITU or whether it's within some of the regional standards organizations in Europe, it's ETSI, you have the IEEE in the US, it tends to be a very structured process. It tends to be bureaucratic. It tends to take a long time, and there are votes. In fact, one example I like to talk about is ISDN, right? It took more than a decade. It took probably close to 15 years for the standards for ISDN to be developed, to be finished, And at the end of the process, people said, ISDN, what does that stand for? I still don't know. And then nobody wanted it, right? Nobody wanted it. The Internet standards process is completely different. So the Internet Engineering Task Force, right, the way they describe it is rough consensus and run code. You don't have to wait to get it perfect. You get close, you put it out there, you run it, and you improve it over time. It's iterative. It's iterations, and it's improvement. It's rough consensus. And it's much, much faster. And it's all based upon the requests for comment, these RFCs that come in. And I don't know how many people here have ever been to an IETF meeting. I suspect some of the people here have been to IETF meetings, right? And they meet online, but when you go, you also have physical meetings, and people are there, and they're all sitting in rooms on their computers and on whiteboards and with projectors showing the various algorithms, and there's debates back and forth, but there are no votes. It's rough consensus. You know how they know when there's rough consensus? The rapporteur, moderator, after things kind of calm down in the debate, they say, are we ready to hum? And they call for a hum. It's not a vote. And you listen. Seriously, the first time I was at an IETF meeting, it was like one of these things like, oh my God. This is how we make standards? But it works. And it's rough consensus. It's not perfect, but it works. Organically, bottom up, informal, even today. And it's very effective, and they can move on a dime. They can reach consensus quickly. If there are important questions, important issues that have to be addressed technically, they can pull it together and they can act. That's not the normal, the traditional process. And as a result of that process, there's a guy who at an IETF meeting, 13, 14 years ago, Steve Deering, he said, what we have, really, we've created a technology hourglass with IP, Internet Protocol, sitting there at the bare layer in the middle. So we have a standardization, a global standard for IP, for Internet Protocol. And then we can have innovation and differentiation at the lower layers, right? The physical connections, the network layers, layers 1, 2, and 3, right? And those can change as long as we have IP in the middle, because then above that, we have TCP IP, UDP, but above that, we then can get even to the applications. Huge amounts of innovation and differentiation. And by the way, for a long time, the traditional communications companies laughed at IP and TCP IP. They said it's never going to work. Nobody wants it. The phone companies all wanted, X25. IBM was convinced it was going to be SNA. Where are they today? Right? IP wins. In fact, Vint Cerf, one of the fathers of the internet, who's also an old friend, he jokes, and he has a T-shirt that says IP over everything, and it's a picture. And it's a picture of a dog with his leg up. Vint's great. But no, seriously, what Internet Protocol has enabled, we joke it's not an hourglass, it's a martini glass. At the upper layers, there's a party going on. It's all kinds of applications, whether it's email, social networking, gaming, books online. IP makes that possible because you have in the middle, at the bare layer, a global standard, and everything can work around that. Huge amounts of innovation. Huge amounts of innovation. Global standards are incredibly important. Think about Ethernet, how easy that is, right? And think about the old world, telecom world. Even here in Europe, this was how you connected a telephone, right? This was just in Europe. National standards don't work for global communications. We want global standards. There's something else that's really important, and it really started here. Common law. It's interesting, we like to talk in the internet world about permissionless innovation. I don't have to ask permission to innovate. That's what the top of the martini glass is all about. And there's some differences, interesting, way oversimplified, right? There's some lawyers here, right? So way oversimplified. But common law, one of the aspects of common law basically state, if it's not prohibited, it's permitted. In continental law, it's the reverse. Again, oversimplified, but the bottom line is, if it's not explicitly permitted, you can't do it. It's prohibited. Right? Common law has led to huge innovation in the internet and huge investment. Just 2 weeks ago, Tech City Tech Nation released the data here in the UK. We have, almost 1.5 million people employed in the digital technology companies across the UK, in clusters, not just in London, but across the country. Huge innovation. 45,000 jobs are currently, being advertised for, digital jobs today. Last year, there were over 1 million digital technology jobs advertised in the UK. With almost 1.5 million people working in this field here, because of the innovation, where is the venture capital for the internet and digital technologies in Europe? It's here. It's the common law approach. The countries on the continent, right, we give their eye teeth for this. They all want these jobs. But they're here for a reason. And it is about the incentives. It is about permissionless innovation. It is an environment for investment and risk-taking, right? Because a lot of these startups fail. They don't work. So there has to be an appetite for risk as well as reward. That's really important as well. So there are a number of pieces of this, whether it's bottoms up, whether it's rough consensus, whether it's common law, it's all important. It's global standards, not national standards. So why is this important? Because it is about the future, and it is about the economy. In the US, looking at the 20th century, you can see that from the information economy, like here, has taken over. At the beginning of the last century, only about 18% of jobs were associated with information. It was close to 60% by the end of the century. McKinsey did a study recently looking at the internet and innovation, and it found that in mature economies, 21% of GDP growth of the last 5 years were associated with innovation related to the digital technologies in the internet. They looked at 13 countries overall, and across those countries, almost 3.5% of total GDP in those countries were related to this sector. And 75% of the internet's impact is on traditional industries, the brick and mortar industries, the manufacturing industries, the shipping, transportation industries, finance, banking, right? We all, hear about the big tech industries, the Facebooks, Googles, right? But the impact of the internet is not just on them. They're enabling, right, this impact across the economy on the traditional industries. And 75%, according to McKinsey, of that impact is on the traditional industries. And there's a really interesting book called Economic Transformations by Lipsey, Carlaw, and Becker. And they look at what are called general purpose technologies, GPTs. The internet has all of the characteristics of general purpose technology, like the printing press, railway, electricity, computers. The World Bank did a recent study looking at general purpose technologies and said broadband is a general purpose technology. Right? It's not by themselves interesting, but everything else is built on top of it and affected by it. That's why it matters. And the World Bank did a study that said that connecting to the internet and connecting to broadband has and this is not correlational, this is causal, that in an emerging economies, increasing broadband adoption by 10% can increase GDP by almost 1.5%, and in developed countries by over 1%. It matters. It really matters, both socially and economically. So, why did I call this talk the paradox of the internet? It's because we have this trend of decentralization going from big iron to nano computing. We have the decentralization of compute. We have the Internet of Everything. We have this decentralization of the internet. We have this very broad, decentralized, multi-stakeholder process for internet governance. That trend is inexorable. The paradox is, just at this point in time, we have governments that want to reverse the multi-stakeholder, decentralized approach to governance. There are governments that are threatening this open internet, this bottoms-up, this less formal process, this transparent process. There are proposals being made globally to recreate silos, to have national standards instead of the global international standards, to have forced localization of content, devices, data, right? Your data has to stay in country. It can't move across borders. Software, same thing, localization. And there are efforts to reimpose the old telco model of command and control on top of this internet, which was, as I've pointed out, developed in a completely different way. Now, why is this happening? Well, there are real issues facing the internet. One of the biggest ones is, how do we extend the internet to the 3 billion, 4 billion people that are not connected today? There's probably 2.5 to 3 billion connected out of 7 billion people on the planet. And if it is as important as I've said, everybody should be connected. So there's a challenge, an important issue. How do we connect everybody? And the Turing Fund is helping with that. That's great. Then there are the safety, security, privacy questions. These are challenges. And there is a role for government here. How do we protect children? How do we catch bad guys? How do we deal with fraud? How do we deal with crime? By the way, none of these things are unique to the internet. We have thieves in the real world. We have bad guys in the offline world. We unfortunately have, child predators in the offline world. These are not unique to the internet. But because of these issues, which are very important, which we have to solve, and we have to solve collectively as part of the global community, as part, I believe, of this multi-stakeholder approach. But because of these issues, there are some governments that are using that as a reason, as an excuse to reverse the decentralized process of internet governance. Some of the work that I've done recently was a chapter 4 in the publication called the Global Information Technology Report, published by the World Economic Forum. And I've looked at both technology and policy issues related to the Internet of Everything. Right? So there are important questions. Some are pure technical, like reliability, scaling, power. Some are more legal, just the policy side. Data localization, access to data, open data. Who owns the data? And then there are those in the middle that are real issues that are the technology intersecting with policy, standards, interoperability, security, privacy, spectrum, and so on. These are real issues that we have to resolve and address together. So when I think of governments that are trying to reverse this open, bottom-up, multi-stakeholder approach, I don't want to be too cynical, but there are some governments that are well-intentioned but not well-informed. There are other governments that are very well-informed but not well-intentioned. Those are the ones that I worry about. And part of this is, we had a set of old assumptions. In the telephone world, there were 5 assumptions that were correct. The product was voice. The metric by which you measured it, billed it, and regulated it was the minute. And then, based upon sort of economic principles, if you have incremental cost, you have incremental charges. Well, the longer you talked, the higher the cost, minute charges. The longer the distance, the higher the cost, long distance charges. Where you were located affected the cost. You had different charges for where you were located. But in the new world, the new reality of the internet, the IP network, the product isn't voice, it's connectivity. The metric is bandwidth or throughput. And these networks are distance, time, and location insensitive. So the old assumptions are running into the new realities. Completely different world. And yet there are some who want to impose or maintain the old assumptions of the telephone world and move them over and impose them on top of the internet. That, I think, would be a problem. Now, how are we addressing all of these problems that I've raised? Well, the fact is, the internet ecosystem is addressing these challenges, all of these various organizations. And again, there is an appropriate role for government to be part of that, but not to own it, dominate it, to the exclusion of everybody else. 3 quick examples. Botnets are a real problem in the security area. So there are in some countries, you have internet service providers creating codes of conduct. And I know that BCS is very interested in codes of conduct, right? And we had a conversation earlier today about that. So that's happening in Australia, Japan, Germany. Then there are industry-led coalitions. For example, Microsoft is leading one dealing with botnets. And then there are the ad hoc working groups, such as the Cornflictor Working Group. And that was one of the, until most recently, one of the worst of the botnets. What's interesting about this data localization, which is in the name of security, keeping all of my data in my country. I had a very interesting conversation with a minister from a very large country that actually passed a law about data localization. And he called it a political law because he didn't know how to implement it because it did not comport with technology or it didn't make sense to him. And he basically admitted that if it went into law, he wouldn't be able to use an e-ticket. He wouldn't be able to use his credit card outside of his country, right? It was done in the name of maintaining security. In fact, Sweden has done a study that basically the bottom line, if you can't transfer data globally, you're not going to have trade, right? It would seriously impact the global economy. You can't have global companies without global data. So these efforts to have data localization in the name of local innovation, either as a using it as a non-tariff trade barrier, or in the name of security, would have tremendously adverse impacts on national economies and the global economy. Recently, just 4 examples of proposals that were made in global bodies to regulate the internet by shifting from multi-stakeholder to multilateral. One was from India, Brazil, and South Africa. That's why it's called the IBSA proposal, was to create a new global body to oversee internet governance. In India, there was a proposal to create a committee for internet-related policies based on this IBSA model. There were calls for a UN code of conduct for the internet. And then just in December, China proposed to create a new UN body, a new UN organization to coordinate all internet activities. Remember I talked about that 2012 meeting where those proposals to regulate the internet were voted down? The Economist Intelligence Unit looked at those, right? And it's not surprising, right? That first of all, based upon some World Bank analysis, countries are divided into 4: full democracy, flawed democracy, hybrid regime, and authoritarian regimes. Not surprising, 90% of the authoritarian regimes voted for those regulations. 90% of the democracies voted against them. That's all you need to know. So, we are really at the crossroads. We have to get the balance right. We have some big decisions to make. There are legitimate questions about safety, security, privacy. But on the other hand, we have innovation, growth, democracy, access to information, and access to the internet globally, right? This is the paradox. We have this, inexorable diffusion, decentralization. We've had an internet governance process which has been bottom-up, multi-stakeholder, open, transparent, and it's been decentralized. The question, are we now going to shift to a top-down command and controlled, centralized internet governance model? It makes me think about we're really at this crossroads. And when I think of crossroads, I think of 2 American poets. The first, Robert Frost, some of you may be familiar with him. And he had a poem, The Road Less Traveled. And there were two roads diverged in a yellow wood, and I'm sorry I could not travel both because they were both beautiful. 2 roads diverged in a wood, and I took the one less traveled, and that has made all the difference. But he had 2 choices, and either one would have been fine. That's not the crossroads I'm thinking about. I'm thinking about another American poet. I call him a poet. He was a blues singer, Robert Johnson. I don't know how many of you are familiar with his crossroads. Mississippi Delta Blues. He was at the crossroads of whether he should do a deal with the devil. He was struggling about the deal with the devil. Which path do I take? That was his crossroads. I think that's the crossroads that we're at. He's the poet I think of when I think of this crossroads. We can't afford to take that. I think we have to make some very clear decisions because we cannot afford to lose what we have that's been built up from this very broad, transparent, bottom-up, organic, multi-stakeholder process. Niels Bohr, a Nobel Prize-winning physicist from Denmark, said, "How wonderful that we have met with a paradox. Now we have some hope of making progress." That brings me back to being the recovering regulator in the 12-step program. You can't, right? I can't reform until I know there's a problem, right? So every morning when I say I'm a regulator but haven't regulated today, I'm admitting that's a problem. And I think Niels Bohr is right. We are at that juncture. We've met with a paradox. Now we have some hope in making progress. Thank you very much.
Okay, thank you very much for that brilliant lecture. I'm sure there are lots of questions in the audience, so we're now open for questions both from the audience and from the web. So my colleague Janine Mitchell will be alerting us when we have questions from the IET.tv or Twitter. Can I just ask, there are roving mics, which has already arrived at the first person. Please will you make sure before you ask your question you do get a roving mic, and we'd be very grateful if you'd let us know who you are and what your affiliation is. So thank you very much. Over to our first question.
I run a company called Intelligent Networks. I was on the first ever data team in 1973 in the UK on X25, so and so I was looking at you. I mean, the key question, and Vince Cerf said it in 2006, why aren't we moving from IPv4 to IPv6? Because the old question is you want to be able to directly connect to devices, and with IPv4 we're running out of numbers. So being able to connect to all these devices will give you transparency.
Oh, yeah, I'm Mike, thank you. So the question is, why aren't we moving faster on IPv, on the transition from v4 to v6? The good news is we actually are now. So in the adoption curves, it's very, very, very long tail, and we're starting to go up that hockey stick. Well, no, we've already run out of v4, but I think of v6 as really having three legs to the stool. All right, you have the networks have to be capable, right? All of the major networks in the world now can support v6. Second, you have to have devices. All of the devices, smartphones, tablets, PCs, all of these connected devices in the Internet of Things all have v6 stacks. So all of the new devices are v6 capable. When you have the app, then it's applications. But when you have the networks and you have the devices, now the application providers, the content providers, have the reason to also make the transition. So what we've seen is that it's no longer this long leg of this adoption. We've already begun to move up, and we're seeing very significant both deployment and adoption of v6. We're on our way. Now, that's good news. I'm optimistic, but I'm impatient. Okay? I think we can do more to accelerate, but the question is what needs to be done to accelerate. But we're on our way. But I am impatient as well, but I'm optimistic. Right.
Thank you. My name's Charles Ross from the Real Time Club. There are 2 or 3 people in this room that back in the early 70s making a proposal to the Select Committee of Science and Technology of the House of Commons to suggest that we had the technology to get all our medical records online. Now, about 10 or 15 years ago, the government tried to do this in this country, and we wasted £12 billion. How do we educate our governments?
Very carefully. It's a huge issue everywhere. And again, that was one of those cases where I think it was very, very well intentioned. And if you look at the promise of medical, we're just now getting to the point of being able to have medical records, but then there's the transportability of the medical records, and there's clearly the security of the medical records. It's a lot more difficult than people thought, right? It's not just about having the vision that will connect everything. The details make a huge difference. And what I've experienced globally, because my portfolio is a global portfolio, is that there are a handful of political leaders who actually understand the technology and get it. You really need to be also, though, working with the layer down of the technical experts, right? People use the word technocrat in the pejorative, but technocrats are really important as long as they don't become too bureaucratic. And I think that's part of it. And it's a long tail learning curve. And there have been huge mistakes. It's not just, by the way, in medical records. Think about the changes in air traffic control systems. Think about all of the other government programs that were well-intentioned that went off the rails because we didn't bring together the right group of people at the right time that made it realistic. It's very difficult. But I think we're getting there in the medical records.
Thank you. Brian Nussel, retired fellow of the IET. Tammy, one thing you didn't address is the question of any form of policing of the web. I mean, in this country, we've seen major problems with pornography. We've had major issues with ISIS. We have problems in terms of theft from the web. I mean, one of your slides talked about the bad guys. Now, if I get robbed in the streets here, I can go to the police. If I get robbed on the web, what do I do?
So no, that clearly is one of the issues, and that is where the role of government working with this broader ecosystem is, I think, extremely important. But look, the reality is that you periodically do see, for example, with some of the child pornography. I mean, there was a recent massive arrest in this country and other countries where police working together with internet experts globally arrested a lot of people. There are opportunistic crimes, both on the streets, but also online. One of the things that is the most important, frankly, is part of the education of good cyber hygiene, if you will, so that you don't get hacked. It's about people not using password as their password, right? Or admin as So it's a huge education effort. But as a former regulator, knowing what I didn't know and knowing about the capabilities of various government agencies, turning to government alone to solve those problems isn't going to solve the problem either. It has to be a partnership between government, the research community, the technical community, the private sector, and that's where we've seen the success. It's been because of that public-private, academic, technical partnership attacking those issues. That's when it's been successful. Oh.
Hi, my name is Lee. I'm director of Plum Innovation Limited. We provide innovative solutions for UK schools, education. My question is, how can we protect end users from invasion of privacy in this big data era, including end users? For example, if I Google something on the Google page, and then looking for a washing machine or a computer, next time when I go to some other websites, which is totally a different site, somehow some adverts will pop up with something I searched for. I don't think I agree with this, though, but how can we protect our users? Thank you.
Yeah. So great question. There are a couple of issues there. One is the people who are popping up on the edge may not know anything about you, who you are, where you live, but they know that you search for a washing machine, right? So, in some societies and cultures, since they don't know anything about you or even who you are, it may be annoying, but it hasn't violated your privacy. In others, people feel as though it's violated their privacy. So, so this is one of the things that's having to be addressed.
Since we're working for education, we work with many schools, and many latest apps, for example, on tablets or on computer, they collect users' activities or behaviors on the network. and then they generate how the big data is. And sometimes a kid's activities or behavior are being collected by these software companies. And then for parents concerned, is that kind of like innovation of privacy, because how kids...
Well, children have always been a specially protected class of citizens, right? Because they can't always protect themselves. So there are, for example, and there are different national laws, and this is again the appropriate role of government, that affect that. So in the United States, there's something called COPA, which is the Child Online Protection Act. And there are specific laws that actually are designed to protect children when they're online. Of course, it's not always easy to know when somebody is online is a child, but clearly when they're in school. In fact, there was an issue similar in the US with one of the education companies that was beginning to track, for good reasons, track the students' test scores, right? They would, because what you want is the feedback.
Yeah.
But the question is, how long did they retain the data? Could it be made available outside of the school? Could it be made available to the parent? Was the data eventually just erased? Right? And part of the public and transparent discussion that came out of that, the company developed a sort of self-enforcing set of rules. It was, because of the public debate, that what they did was they said at the end of the school year, the data disappeared. Because you need some of the data, but for those students with that company, the data were only made available within the school. They were not made available more broadly on the internet.
So that's only agreement between the school and the software company. So
In
say
that
within a year,
case.
and they will delete all the data.
Yeah, in that case, that's what it was. But again,
Is that protected by government rules?
It does, but again, what you want is the outcome for the protection, and having the public debate about it is actually the first step as part of resolving it. Can it be solved by the companies? Can it be solved by for example, the contract from the schools that can enforce it through the contract? Or does it require a government regulation? In the US, it's in the context of the Federal Trade Commission that has online rules protecting children. So, it's this, again, it's balancing. It's looking at the balance and getting it right. It's not one or the other. It's getting the balance right.
Bottom up. Thank you.
Over here. Oh, okay, I'm sorry.
I was curious, have we got an internet one?
Oh, we have an internet. Great. And then we want to go to the upstairs. We're waving. Okay, we'll go upstairs. We'll go to the balcony after the internet.
Rick Chandler, chairman of the Communications Management Association, which is part of BCS. Taking that thing that you just mentioned and looking at Obama's recent statements about America owns the internet and thinking about your picture of global domains, do you think that Obama has the balance right, and is he educated enough to understand the implications on the rest?
I'm not going near that one.
I mean, he needs education, really. I mean, can you imagine the reaction of particularly Europe and the rest of the world when we have new privacy regulation, we're looking at net neutrality, we see 4 or 5 huge blue dots on your picture there. But if you won't go near it, fine. But I mean, I just think we get very worried when we see that global dominance perceived from the top rather than the multi-layer.
Well, I think, yeah. So I'm going to avoid part of your question. But I think what he was referring to in a general sense was sort of the history of where the internet came from. And if you look at, those blue bubbles were big, but if you added up all of the other bubbles, right, they overwhelmed those blue bubbles. So the internet is today completely global. Remember, it's also the Obama administration that has proposed this IANA transition to take the contract with the Department of Commerce and completely privatize it and get away from any government, including the US. And that's one of the criteria for the IANA transition, that no government nor any multilateral organization should take control of the IANA process. And all of that should be completely privatized. So, I do think, and that is the Obama administration, which is getting it outside of the US.
I've been building comments on
Yeah, so he wasn't on the mic, so, he's been building, applications and working with the IETF for a long time, and comments like that worry him. I think that, again, I'm not going to comment on those comments specifically, but if you look at it, the internet has become global, even if it started in the US, and if you take a look at all of those bubbles, right, and you add up all of the bubbles except for the blue, they overwhelm the blue. So it is the internet is completely global, and that's, that is the way it is and the way it should be. Let's take an internet question.
So I've got a question from Jonathan Robinson that's been tweeted, and it says, why did your regulation slide not include the FCC Title II net neutrality plans very current in the US?
I'm sorry, which slide?
The regulation slide.
So I have to go back and figure out which of I had the 4 examples. So what he is referring to is that within the U.S., within the net neutrality debate, there's a proposal that's going to be voted, I think it's next week, by the FCC, whether to impose what's called Title II traditional telephone regulation on internet broadband service providers in order to, that would be the legal structure on how to enforce net neutrality. Without getting into a very deep dive into the weeds of US law, the FCC, and actually starting when I was there, we developed what we called the open internet policies, the principles about no blocking, no degradation, that people should have access to any legal content and applications, connect their own device. And the FCC 3 times tried to adopt, or did adopt those rules, and they called them net neutrality. By the way, net neutrality means different things to different people. They adopted the rules under a part of the Communications Act called Title I, which is a basic enabling part of the US telecom law. And 3 times they lost in court. And so the current FCC is going to, announced by the FCC chairman, to use traditional telephone regulation to do that. But he says he doesn't want to impose all of the Title II, right? He says he doesn't want to require unbundling, he doesn't want to have price regulation. It remains to be seen whether that actually will sustain an additional court challenge. Personally, I would have preferred that the FCC did not take a Title II approach. I think it is fraught with all kinds of risks because of litigation. They could end up regulating much more than they want to, even though the chairman says he doesn't want to impose traditional telephone regulation. The devil in this is really in the details, and it's because of the way the FCC's enabling law was written in 1934, right? In fact, the 1934 law was an amalgamation of the Interstate Commerce Act from the 19th century with the Radio Act of 1927. They stuck them together, and they called it the Communications Act of 1934, and it's had some amendments along the way. But it is essentially, right, a late 19th, early 20th century law that has not been rewritten. And the problem there in the US is it's limited the FCC's degrees of freedom to not regulate in certain ways, right? And that fundamentally is a problem. It wasn't on there because it hasn't happened yet. And it's very idiosyncratic to the US because of the nature of the structure of the law and the court cases that said the FCC couldn't have light touch under this other title. That's why. Sorry for the long answer, but Don't get me started on net neutrality. Up in the balcony.
Good evening. My name is Donna Jacobs. And first of all, thank you very much for your presentation. I found it very illuminating. Secondly, my question refers to the Proteus pill. If a patient is on a medical treatment with involving several drugs, is the Proteus pill conceived to help the patient or was it conceived only for monotherapy? Did I?
Yeah, I'm not quite sure I heard all of the question.
The Proteus pill. The Proteus
Oh, the
pill.
Proteus pill, yes.
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 Was it conceived to deal only with, to help the patient only when the patient is on monotherapy, or it can help if the patient has a medical treatment involving several drugs? Oh,
okay. So I don't know all of the, enough about the company Proteus and what it intended. But, so I don't know whether it's with multiple drugs or only certain drugs. But the concept, and I don't know exactly which medications, right? But it's being used for multiple different medications. And it's, and the question is, how successful will it be? And will other drug companies use the Proteus technology, which is the chip inside the pill? Right? The opportunity is that this could be used in lots of different kinds of medications, right? And not limited to one or only a handful. But it's a great example of thinking about things completely differently, right? And in this case, it's not, am I waiting that the communications will tell me something? It's the lack of communications that tells me something. So it's taking a lot of this and turning it upside down.
I was just wondering if you have to swallow so many chips.
It's in every pill. Yes. So by the way, there are. So then the question is, what happens?
And then will
But
they not
so
be...
so is the chip biodegradable, or is it so small that you don't notice, and it just goes into the plumbing system?
Will it not be passed by the digestive tract? Okay. Thank you very much.
It's in each pill.
Thank you very much. Thank you.
Any more in the balcony before we come back downstairs? There's on this side. So maybe while you're walking over here, we'll take one from down here. How's that? The bright lights make it difficult to see. Sorry.
Your lecture is very much concerning the paradox of a technology which is less than 40 years old, running against a vested interest that started with the Industrial Revolution and is coming up to 350 years old. Do you feel, or what do you feel, the immovable object of command and control, with its incredible vested interest in time and money, how does the bottoms up have any chance, and what do you think the chance it has against that enormous vested interest, and how can it actually manage to beat it?
That's a great question. What we've seen is there have been some examples where there have been some very large vested interests that did not want change. Change is really hard, right? It's this, the assumptions, the old assumptions and new realities. But the bottom up, the crowdsourcing, the popular support for the change actually has driven change. I'm actually very optimistic, maybe more optimistic than I should be, but I'm an optimist by nature. I actually think that the bottom up, especially if you can organize it, can really have change. I mean, frankly, a good example is the net neutrality debate in the United States. Not that I necessarily agree with what the outcome is, but the advocates who I think were well-intentioned about wanting to protect against what they see as anti-competitive behavior, were able to get 4 million people to send emails to the FCC that basically changed the public debate. Now, I don't think necessarily that's the right outcome, but it's not a vested interest versus not. I think, that's a separate issue. I do think that there are popular, the ability to organize. What's one of the things about the internet? You can't hide things on the internet, right? It's self-organizing. It is this bottoms up. And there is this groundswell. And I think that part of the answer is education. It is the free flow of information. It is maintaining and fostering the bottom up. And by the way, that's why there are some governments, right, on that right authoritarian side that don't want open data. They don't want an open and free internet. They're afraid of it. Why? Because, even if they've been, an entrenched interest in power for centuries, right? The fear is what happens if now people can actually talk to each other. So their fear is my optimism, right? So I'm much more optimistic.
Okay,
one last question. All right, so we'll all the way up in the top.
Ivan Atanasov, retired. My question is, are we fueling the fire that will later consume us?
In what
I know it's not very optimistic.
So is that being optimistic? I'm not quite sure about the question. What is the
fire exactly?
Yeah, what is the fire?
Of media, of the retail park. Sorry, the media, the retail park. Marshall McLuhan quoted it, but he's long since gone. But that was his point, the computers coming in and the media effect.
I'm not quite sure whether we're feeding the fire that's going to consume us. I don't think so. I don't see this as consuming us in that way. Again, I'm very optimistic.
Maybe the recognition of the information is so fast that we haven't caught up in understanding it.
Yeah, no. In terms of not fully understanding, but again, that part of that is there's so much data. We've only begun to look at 0.5% of it. How do we use it? How do we process it? How do we understand it? And it's not just about the technology, right? It's about becoming, it's about learning how to incorporate the data in our lives. How can we use it to affect process? How can we use it to improve our lives, improve the economy? There are all the positive social impacts. So, part of the answer to your question is, I would argue, more analytics, more understanding, and having the open, transparent conversations that as we share the data, we can learn from one another, right? It's not just about the technology. And we need more of that, not less of that.
Okay, thank you very much. I'm sorry that we don't have time to answer all your questions. I would now like to invite William Webb, President of the IET, to give a vote of thanks. And whilst he's coming to the stage, can we thank Robert for his lecture? Thank you very much.
Thank you, Liz. So it's traditional in the vote of thanks for the Turing Lecture to say a few words first about the speaker. Now, of course, you've heard a lot about the speaker at the start of the talk, but happily I've got some inside knowledge because I've known your speaker for over a decade. But the first problem I've got is I'm not quite sure what to call him. Now, you might think I'm wondering whether to call him Robert or Bob, but actually he's often known by Pepper. But in Britain, to call someone by their surname is quite abusive, so I always struggle a bit to call him Pepper, but I'll go with it. And I first met Pepper when, as you heard, he was at the FCC, the Federal Communications Commission, and something like a decade ago, he retired, some retirement. And when he put up that chart showing the interconnectivity of the internet, I did wonder whether actually that was really a map of his plane flights since retirement. And it says in the notes that I was given that he has some leisure activities, which I find hard to believe, and one of them is visiting art galleries, and that seems very difficult to do, apart from perhaps as a quick glimpse of them as he whizzes past. But the other one is watching films, and I can believe that, because on all those aeroplanes, I'm sure there's plenty of films to watch. But actually, I like to think of those interconnectivity maps as a map of his personal interconnectivity, because he is an astonishingly connected man, connected both to a huge number of key individuals all around the world, but connected in an incredibly multidisciplinary sense. And you've heard a fascinating talk that spanned technologies, applications, regulations, government. And the whole point of the talk is the complexity of the situation facing us with the internet and how we need to grasp all those different areas in order to be able to move ahead with some really challenging but critically important aspects. And that is where we really are incredibly lucky to have individuals like Pepper who have that grasp, who can talk across all those different areas on a global basis with a huge background of experience. So, in time-honored fashion, I'd like to propose that the best thanks of the BCS and the IET be accorded to Dr. Robert Pepper for his delivery of the 2015 Turing Lecture. And between us, we have a small gift for Robert to commemorate his evening tonight.
So, thank you very much. Thank you very much. Okay, thank you very much for coming this evening. I hope you've all enjoyed the lecture. And I hope that you will continue the discussions over drinks shortly. But before I let you go, I'd like to make you aware of two forthcoming events. Firstly, the BCS Lovelace Lecture, which will be held at the Royal Society, and the speaker will be Professor Stephen Ferber from the University of Manchester, who'll be talking about computers and brains. And secondly, the IET Clark Maxwell Lecture, which will be given by William Nuttall from the Open University on Britain, nuclear energy and the future. And I note that they seem to be on the same date, which means you're going to have to choose. So obviously also means that we need to coordinate our events better, but I do hope that you will attend one of them and enjoy them both. Okay, so to close, first of all, I'd like to alert you to expect an email from us asking you what you thought of tonight. We very much appreciate your feedback, so I look forward to that in advance. Thank you. For those who want to continue discussions afterwards, there will be an opportunity after this finishes in the library and the Georgian room, so I hope you will become our guest for a short while. Finally, I'd like to obviously thank Robert again for his excellent and thought-provoking lecture, and thank you for coming here this evening to the Royal Institution. Hopefully we will see you again next year for the 2016 Turing Lecture. The speaker will be James Powell, who is the Executive Vice President and Chief Technology Officer at Thomson Reuters. He will be giving a talk describing how the use of technology has transformed both financial markets and global news gathering, referencing Thomson Reuters as well as other global players. So if you're staying for a drink, I hope you do carry on the discussions. I wish you all a very safe journey home, and I now declare the Turing Lecture closed. Thank you very much.